In this lesson, we'll talk about object lifetime. When you create a new instance of objects within your project, that object will only be around for a limited amount of time. As long as your application keeps a reference to that object and continues to use the object will stay alive. However, if you were to close the application, or if in your code the reference to that object goes out of scope, then the .NET Framework will flag that object to be removed from memory, and a special application called a garbage collector will come around and remove that object from your computer's memory and basically clean up after your program. I've already detailed all of that in the lesson text for Lesson 13, and I made the analogy of an object having a lifespan, just like all living things have a lifespan. You have a birth and eventually you have a death. Within object-oriented programming, those are important events in the life of an object, and you can write code that executes whenever those events occur. So I've created a new project and called it Lesson 13, and to the project let's add a new class. We'll call it car. And I'm going to take a moment or two to just flesh out this class with some private fields, some public properties, and maybe a method or two. So I'm going to pause right now and do a little bit of typing. Okay, so what I've done was created 3 private fields called make, model, and elapsed mileage, and then I also created public properties for each of those: make, model, and elapsed mileage. When a new instance of our class is created, we can write special code that's called a constructor, and that constructor can set up the initial values for their private fields, or it can create a connection to the database, or it can open up a file on our hard drive, or any other work that needs to occur before the car is really usable by our application. To create a constructor, what we can use is the template that's provided for us whenever we add a new class within C#. All I need to do is just highlight this code and hit the delete button on my keyboard, and you can see now a pretty clean definition of an empty constructor. Notice that first of all the constructor has a public scope designation, and then it uses the name of the class as its identifier. So if you need to ever create your own constructor and you don't have that template, you'll need to use the same name as the name of the class. So let's go ahead and flesh out this a little bit more and initialize our private fields using a constructor. Now in this case our constructor doesn't really do a lot because these would be the initialized values for our data types anyway. A string will be an empty string and an integer will be 0. But I could change this if I needed to based on my business rules, to something like default, or maybe 10 for elapsed mileage, or whatever the case might be. This is called a default constructor because it is the one that's provided by default. It takes no arguments, and it's pretty much the only constructor that you probably need to use. But there is a way to overload a constructor to make a second constructor that has essentially just a different method signature. So let's go ahead and create one of those right now. And there's a really tangible benefit to creating an overloaded constructor. So in this case, what we're doing with the overloaded constructor is that we're allowing the user of our class, whenever they create a new instance of our class, to go ahead and in that first line of code define what the make, the model, and the elapsed mileage is, and then we take those values and set them equal to their corresponding private fields that will essentially be hidden by our get and set properties. So it just saves a little bit of code. Let me show you the difference between using the default constructor and then populating each of the properties individually, as opposed to just using the overloaded constructor, which allows us to pass the values in as arguments into the constructor. So I'm going to double click my button, and here I'm going to create a first instance of my car object. So car, my car equals new car. I'm going to open up a parenthesis and look at my IntelliSense knows that I have two constructors. So I see 1 of 2, which takes no arguments, and then 2 of 2, which takes 3 arguments. So I'm going to use the first one for now. And now we'll do my car dot make equals Oldsmobile. My car dot model equals Cutlass Supreme. And then my car dot elapsed mileage equals 200,000. 200,000. There we go. Okay. So there's about, what, 4 lines of code there. Now I should be able to accomplish the exact same thing, and we'll just do this my car 2 equals new car, but this time I'll use the overloaded constructor. Now the way that I go back and forth between the IntelliSense, between the two overloaded versions of this method, is to use my up and down arrow on my keyboard. So I use my down arrow, I can just keep on using the down arrow, I can keep on using the up arrow, and so you can look through the various method signatures that are available. So in this case, as a helper, I'm going to go ahead and select the second of 2 and type in Oldsmobile. And then 2. Now I was able to accomplish in just 1 line of code what it took me 4 lines of code to do here. So it's a little more compact, a little more readable, at least to people who are in the know about overloaded constructors. Now, just as objects have a birth, they also have a death, and the way that you write code for the death of an object is to create a destructor method. Or simply just a destructor. So let's go back to our car class and create a destructor and go to the very bottom. And this time I'm going to use the tilde key, which is right above the left tick next to the number 1 on my keyboard, and then the name of the class. The name of our class is car, so that is an empty shell of a destructor for the car class. So here we might want to do things like say the values of car in the database. We may want to close some files, or whatever the case might be, something that has to happen in order for our application to shut down nicely. So basically, a destructor allows us to capture an event that occurs right before the garbage collector destroys our object and takes it out of memory. So, like I said in the lesson text for this lesson, typically you're not going to have to worry about this. If you're using some external resource like a database, like files, maybe some handles to the Windows API, and I listed a couple of other examples where this might be helpful, then yes, you might need a destructor. This is more to just round out your understanding of the lifetime of an object. So what we'll do here is just put a message box and pop it up whenever the destructor actually gets called by the .NET Framework, and that message then is passed to our car object. And I'm just going to paste in some code here. We'll just pop up a message box called destructor. And let's do the same thing then for our constructors. Let's see, here we go. And we'll paste it into this one as well, but we're going to put here overloaded constructor. Very good. Okay, let's go ahead and save that, and now let's run our application. Well, before we do that, let's review what's going to actually happen. Let's take a look at how our class is being used again in this button 1 click event. So first we're going to create an instance of my car as car and set it equal to a new instance of car. The new keyword is what actually calls our constructor. So if we were to do a line of code somewhat like this, my car and then my car equals new car, where do you think the constructor would actually get called? It would get called on that line of code, not on the declaration here. So if we were to do it this way, we would expect that the default constructor would get called whenever we hit this line of code, and so we get one message box. And then whenever our overloaded constructor is called, we would expect to get a second message box. And then we're kind of at the mercy of the .NET Framework from that point on. We no longer have references to my car. We would be out of scope at that moment, and would just wait for it to clean up. Now there's one way that we can accelerate the destruction of an object, and that's to shut the application down. So we would expect then to see two message boxes at the very end, one that destructs my car and the other that destructs my car too. So let's see if that's exactly what we get. Hopefully we'll run this and won't have any bugs. Okay, very good. So I'm going to click this button. Okay, it called the constructor, so it hit that second line of code there. Now it called the overloaded constructor, so it hit that bottom line of code that's just barely out of our viewing area. And so now we can just kind of sit around and play the waiting game. And at some point, if we waited long enough, the .NET Framework would get rid of the objects, and we would see a pop-up message box. But to accelerate that, I'm going to go ahead and close this application down by clicking the little X button in the upper right-hand corner. And you can see here that we get a call destructor. Now I didn't click on the button. When we close the application, obviously that's a signal to the garbage collector that we need to take a lot of stuff out of memory, so it's going to expedite that process. And in the process, that destructor message box pops up, and it didn't wait for us to click it because the garbage collector was anxious to get rid of everything out of memory. So we didn't really get an opportunity to interact with it there. But that's fine, but just for the sake of for understanding how constructors and destructors work. So by virtue of the fact that we couldn't really predict when our destructor was going to happen, that's referred to as being non-deterministic. It's because we can't determine the exact moment in time when our finalized method will get called. Therefore, you shouldn't rely on it for something that's very important to your application. You'll need to figure out some other way to accomplish whatever you're trying to do. It's only useful when it doesn't have to save the values of the car object in the database or close any files the car object has open at a specific point in time. If time doesn't really matter, then you're cool to use the destructor. Again, many times you're not even going to need to use a destructor within your class unless you're managing some sort of external resource, like a database or file or whatever the case might be. So I think we've covered the birth, the life, and the death of objects. We talked about constructors and overloading constructors, and then also destructors and using the finalize method. And as always, I strongly encourage you to go through the lesson text, go through all the lesson steps, including the extended readings. Fill out the definitions and the lesson questions, and probably one of the best things you can do is to get your hands dirty and go through the actual exercise and watch the solution for the exercise to see how you did. Thank you.